Theorem 2 says that adjacent angles in a revolution add up to 360 degrees. Now, the word revolution means angles that occur around a point. In other words, if I have a point O here, then there is angle 1, 2, 3, 4, 5, and 6. Then we end here where we started. We then have angles that are next to each other, that are adjacent, and they are around a point. We then call those angles a revolution. Now, this theorem says that if we have such angles, then they must add up to 360 degrees. You know, another way of writing this theorem is to say that these angles are conjugate. Adjacent angles in a revolution are conjugate. To say that they are conjugate means that we're having angles that add up to 360 degrees. And as usual, our theorem has two parts to it. The first part is the given data. So here we are told, or we know, that these angles are next to each other and they are a revolution. In the second part to a theorem is the conclusion, and our conclusion is that they are conjugate, meaning they add to 360 degrees. This is the reason why when you look at our short vision of writing this theorem, or a short way of writing this theorem, we say angles in a ref to mean angles in a revolution. Because remember, our short vision is actually the given data, is the given part of the theorem. Another way of writing this theorem really is to say that angles that are around a point, because we said revolution is actually angles that are around a point. Now, when you are given such angles in a revolution, we then can conclude that when you add those angles, all those angles, they must be conjugate. They must be equal to 360 degrees. That's our conclusion. So those adjacent angles must be equal to 360 degrees. And as usual, if you were to write them in a problem solving, you would add all those angles and say they're equal to 360 degrees, and you give a reason to say why are you saying they are equal to 360 degrees. Well, because I've used the theorem that says angles in a revolution must be conjugate. Do you think that this theorem has a converse? If you think so, please share with us that converse in the comment section.